All right. Unit 9, day 1 notes. Here are your objectives. This is not a long day of note situation. Domain and range from ordered pairs. Suppose that we're just gonna start right out. Suppose that the relation T is defined as follows. The domain values represent X values, range values represent Y values. So domain is here, your range represents your Y value. Okay, so domain are your X values or your domains are your X values or your input. Your range values are your Y values or your X output. Okay, your output values are your Y values. So if it says give the domain and range is always given least to greatest. So, and you do not repeat. So let's say this is your domain is -9, -6, and -6. You just write for domain -9 and -6 one time. Okay, you do not have to repeat the values. Range values, same thing, least to greatest. So your bigger negative is the smallest. So -7, -5, and 8. That is your range value. Those are your range values. Okay, and you'd write them kind of like that. All right, and that's how you kind of put them in italics as well. All right, suppose that the relation H is defined as follows. Give the domain and range, write your answer using set notation. Okay, so set notation is a certain, they want it in a certain way, X such that X is equal to blah, blah, blah. And I will show you how to write that in just a second. Okay, so what I was doing this is kind of set notation. What I was thinking about set builder notation, but so these are the domains are your X values. The first letter or number inside your two terms here, coordinate point or your point, and this is your range. Your range values are your Y. So for domain and range, okay, the domain you're always going to put from least to greatest or in alphabetical order. So 0, 1, and again, if you repeat, just put it one time. 0, 1, 3 is your domain. Range, I guess for this, I'd put the number for, it really doesn't matter. I'll put number 1, and then I'll put it in alphabetical order, A, B, C. I'll put B, C, and then D for your range. Okay, so that's what we got there. Alex, it depends on what they want, or with this. Sometimes they just want it. They just want to make sure that you know how to do it. So if you put them in order, I'm sure they'll still give it to you. All right. So the graph of a relation is shown. Give the domain and range. Write your answer in set notation. Same thing. Domain, range. Even if it's a point, you're just going to, I'd write out the point. This point right here is -1, +2. So -1, +2. This point here is, it looks like 2, 0. This point is 4, 4. This point is +3, -1. Okay, you're always side to side first. So the first number is the side to side, and the second number is the up to down. Okay, so now I have the points there. And for my domain, I'm just going to go in order because your domain are your X values. The X value here is -1. Okay, so I know it's -1. And then I have my X value here is 2. My X value here is 3. And then I have 4. Okay, up here. And then for my range values, I'm going to start down here. It's -1. And then I'm going to go up to 0. Then I go up to 2. And then I go up to 4. Okay, that's how I'm going to do my range. So range is really up and down, and domain is side to side. Okay, for your X values, because this represents an X, this represents a Y. So up and down is your domain, range is side to side. All right. So if I'm looking here, Okay, same thing. And once you know domain and range, um, this point right here, it looks like 2, 2. This point right here is 2, negative 2. And this point here is negative 1, negative 3. And so for your domain and range, you are going to go from side to side for your domain, negative 1. And it looks like you see how there's two different points on 2. I'm just going to write it once, negative 1 and 2 for your domain. For range, I'm starting down here at negative 3, coming up to negative 2, and then going up to positive 2. Okay, and that is going to be your range. Now here, you're deciding if something is a function. So basically for functions, your for your function, what can't repeat are your x values. So if it is not a function, so x values cannot repeat in a function. So that is what's telling you whether something is a function or not. If your x value repeats, it is not a function. Okay. And a lot of these little graphs and stuff, they're going to try to trick you. Okay. So your x value is moon. So this moon goes to 8, pin goes to negative 5, rock goes to 6, sun goes to 7. Okay. Moon, each word here is going to something separate. So basically, what it's saying is for your domain, each domain has to go to one. Each domain has to go to one range. So multiple domains cannot go to go to multiple range. I mean, go to a range. So like if moon also went to negative 5, if moon went to 8 and negative 5, this would not be a function because this first moon can't go to two different ranges. Now, if moon went to 7, pin went to 7, rock went to 7, and sun went to 7, that's fine. Each of them went to 7 one time, that's fine. But moon can't go to 7 and negative 5. Moon can't go to two different things. If moon starts going two different places, it is not a function. Okay, but they can all go to the same place. That doesn't matter where they end. It just matters that every domain is going one time out of it and it's going to a number. It doesn't matter what that number is at the end. So range really doesn't matter with a function. Domain matters. You can't have two domains that are the same going somewhere in two different places. Okay, so in this case, each moon, pin, rock, and sun are all going somewhere different. I mean, they all have one line coming from them. Okay, so this is a function. Yes, it is a function. Now here, X is going to lake, B is going to lake, S, as you see, is going to sun and lake. That cannot happen. S cannot go to sun and lake. S has to go to one place. If S is going to sun and lake, this makes it not a function. That's the only reason because S is going to 2. Okay. Now looking here at the bottom for relations, you're only looking at your x value to figure out if it's a function. If x repeats, then it is not a function. As long as if it's the same exact point, it's fine. So if it was 0, 8, and then 0, 8, and then negative 6 something, and then something, that's fine. As long as 0 always goes to the same number 8. It can't go to a different number. Okay, so 0, negative 3, negative 6, and negative 7, all different numbers. 0, negative 3, negative 6, and negative 7. This is a function. Okay, so the x's, x, 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 do not repeat in this situation. In this one, C, M, Y, F. C, M, Y, and F, all of these are different letters, so this is a function, okay? So if the X repeats, usually it's not a function, we gotta look at it. And they're probably going to throw you some slick ones in here. I can feel it. All right. So now we have this. Each tell whether each is a function. Didn't we just do this one? No, we didn't. Okay. So here, lake, cloud, sky, desk, sun. Okay, those don't have anything repeating from it. So this is a function. Here, look at this 7. 7 is going all which away. Okay, the 1 is fine, but the 7 cannot go to 3 different places. This is not a function. Okay, same thing here. This domain, okay, when you're looking at this chart here, the domain can't repeat. So you see how Y goes to Y and then Y goes to S. Y can't go to Y and S. Okay, and this D went to Y and then another D. It can't do that. Okay, this is not a function. Here, -7 went to 4 and -7 went to 3. -7 cannot go to 4 and 3. 3 can't go to 3 and 3 can't go to 4. Okay, that's not going to work. These domains keep repeating, going to different places. This is not a function. All right. Okay. Here they want you to see if it represents a function. With this, it's you use the vertical line test. Basically, if you draw a vertical line and touch 2 places on a graph, it is not a function. Okay? If you touch 2 places on a graph, it is not a function. So here, if I drew a vertical line, it will just touch this place here. Okay? Same thing there. If I drew a vertical line, it'll only touch this one place. So this one is a function, yes. Okay? If I go here and touch and I draw a vertical line, do you see how it touches here and here? This one is not a function. A circle, okay? Here and here, not a function. All I'm doing is drawing a vertical line. If I touch 2 points, it is not a function. Here and here, I drew a vertical line and it touched that point and that point, not a function. Here, if I draw a vertical line, I'll just touch 1 point, 1 point, 1 point, 1 point. This one is a function. Same thing here. I would just be touching 1 point every time. This one is a function. Okay, so vertical line test. The function is defined by this rule. So this chart is defined by this rule. So X is going to be an input value, if you remember from the beginning. So all I'm going to do is replace X with this. This is my input. Whatever I get out is my Y or your G of X. Okay, G of X and Y are the same thing usually. Okay, F of X, G of X. So if I put in -1 into there, so if I put -1 in for X, that will give me my output, which is this number here. Same thing. So I'm just going to keep going down. -4, again, I'm using this. I'm using G of X equals -4x plus 4. So in place of X here, I'm going to put 0 plus 4, and we're going to answer it. -4 times 1 plus 4, -4 times 4 plus 4, and -4 times 5 plus 4. 4. I said 4, but okay. So all I'm doing is replacing X with all these numbers separately. -1, 0, 1, 4, and 5. And then once I get an answer, so I'll just put in my calculator. Okay, -4 times -1 plus 4, and I get 8. Okay, and then I can put -4 times 0 plus 4. -4 times 0 is 0, plus 4 is 4. -4 times 1 is -4, plus 4 is 0. -4 is -16, plus 4 is -12. So that -16, 15, 14, 13, 12, yep, -12. And this one's going to be -20 plus 4 is -16. Okay. So this is going to be these are my answers that go here. Okay. All all of these answers go here. I'm just replacing X with all these numbers separately and getting an answer. Okay. And that's kind of how it's starting you out so that you can probably graph later. Okay. So this is the function, and it's defined by these. This graph is defined by this function. All we're going to do is the same exact thing we just did, where you are going to take f of x and x minus 2, replace x with these numbers. So this will be, what is it? -5 minus 2, 0 minus 2, 1 minus 2, 3 minus 2, and 5 minus 2. Okay, so -7, -2, -1, 1, and 3. Okay, so these numbers go here. All you're doing is replacing. Finally, oh no, we got one on the back. So functions, this, to be very honest with you, this can get really nasty when they start doing f of x and g of x's. I'm not sure, they'll probably do that, but I'm not sure when. Okay, so, but for right now, they want to just show you the basics. So this is f of -7. So in place of x, you're going to put -7. So they want f of -7. So here, instead of x, they want you to have -7 in there. Okay, everything else stayed the same. X just changed to -7. Now they want to know what's that answer when that happens. So -14 minus 3, -17 is your answer there for f of -7 is -17. Same thing here, g of -6, they want you to replace x with -6, both times. Okay, as you see, x became -6 there, and x became -6 there. I can just throw that in my calculator. 2 times -6 squared minus 3 times -6. Okay, and you got 90. So your answer there is 90. So g of -6, and I put -6 in there, I got 90. Okay. Okay. Same situation here. So f of 4, and they want g of -4. So I'm just going to replace it. So -3 times 4 plus 2. Okay. So that became -12 plus 2 is -10. And then here it's going to be 3 times -4 cubed plus 5. I'm replacing x, as they said there, x with -4. I'm just putting it in. So 3 times -4 raised to the 3rd power plus 5. And I get -187. And that's my answer there. Okay. So that's it for Unit 9, Day 1 notes.